So I'm very excited to be here to share with you. Can everybody hear me from behind? Everything is good, yes. Awesome. So I'm going to talk to you on the topic of scaling mobile development with app as a platform, or AAP. If you see anywhere else in the slides that there's app as a platform. So to gauge how relevant this topic is to you, so I'm going to give you a little scenario and need a little favor from you to just raise your hand if it's relevant to you. So as a software developers, all of us have probably have experience working on a start brand new projects, set up easily and very easy to work with, fun to work with a smiling face. And one of you are experienced doing that. Okay, cool. I hope everybody has that experience. Awesome. But if this project is so good, then what happens is like, oh, let's create more features, let's get more things into it, let's grow it, let's hire a few more developers into it. And over time, you go and grow and grow and grow. What will happen? Yeah, it'll turn into a much larger projects. And what do you guess? It's like it's slightly challenging to work with these days. And of course, you have more developers, but the developers are not as happy as more. Some of them are very stressed. Some of them are very angry working on the projects. And how many of you have experience doing that? Oh, yeah. But welcome to this talk. Hope this talk will be able to help you. And at this stage, we know that it's big and challenging to work with, but that doesn't stop the business sake. We need more features. We need to grow it further. We need to do more stuff. So the next likelihood of steps that we will take is let's grow it further, expand it, and do much more books in our project. So, but then is that the way we should do it? So by then, probably some of us will have been, as a developer, we have grown to a tech lead. So the business came to us, let's create more stuff, let's do more stuff. So there's two options that we can take. One of the options is say, let's do what the business asks us to do. Keep the existing legacy projects and keep working on it. And the other options, maybe tell the companies, oh no, this is no way we are going to do anything. We need to scrap the entire project. Let's start from the beginning. Rewrite everything. But then there's a risk of that. The risk is probably it will have a much more longer delay and durations and risk of even if we have after the delay is even to break feature parity, whatever they're existing, it takes a lot of time. So of course there's the third option, quit and join another company. But no, don't do that. All right. So this is actually a story that I'm going to tell you. I'm Elisha Lye. I'm the tech lead at RA Mobile, and I have been working for mobile development for around 10 years, and I gained some good experience from some of the very good mobile companies like Out West, Below. I've been Below, said hi to Cameron and Sig, some of the Sig colleagues. I've seen hi, Michelle, Kiran, nice to see you. And I've worked with, I've been with REA groups for 7 years. So I have been some experience working from their mobile team, from very start of the mobile teams up to now today. And here, this is mobile, this is REA groups and this is realestate.com.au. So on behalf of realestate.com.au, I want to say welcome. Hope you enjoy the place so far. And since you're here doing a little bit of advertising, we are actually changing the way experience properties, and we are a digital marketing and advertising companies, and we have web platforms, advertising, and more importantly, we have also apps that we serve to our user. So there are all 4 apps that we have. The first apps we have is for the residential property. Some of you might have used it to buy or sell, to rent or whatever. But we also have another apps called the real commercial apps. This is for more of the commercial property, like shop houses and lands and factories. And we also have another apps which is called the Ignite app. This is for our customers agent who are using our apps to track their properties and all these things. And the last one, we have another apps which is for accommodations, shared accommodations, looking for roommates and housemates. So there are quite a bit of apps. So all these are not built within a year. So it has been built through a span of 10 years plus. And so far we have about 15 teams and around 100 plus mobile developers all around various cities in the world. So with that, so how have we grown up to this stage? So I will start off with the story of how it all begins. So back in 1995, the company, like most other companies, we started off in the garage. And back in those days, we just web, right? We have web. So as we know that in 2010 and 2008, I forget, maybe somewhere else, Steve Jobs introduced iPhone. And that's the iOS development that started. That's the time where REA started with our iOS development platform. And then eventually, also we have both the Red app, which is the residential app, as well as the real commercial app started in 2012. So in 2014 and 2016, there's the rise of Android. Google introduced Android. That's the time where we started Android development for our Android app and iOS app. For the Red app and the Blue app. And then later on, we further expand, and then eventually we have like Ignite apps and Flamehead apps back in 2018 and 2020, and up to today. So this time it's no longer just iOS or Android; it's both teams together. So as you see how this grows and how this change actually in the very beginning is clearly before Android team exists. There's only one iOS team we have, and later we expanded on 2014. We created a new team called an Android team. So these are two distinct teams. And fast forward to today, it's no longer one or two teams, it's already 15 teams. And it's not iOS or Android team, it's like a combination of iOS and Android teams. So what the story I'm going to tell you about is the change that we have evolved from the beginning of 2014 up to 2023. So I hope this will provide you some ideas of how our REA has evolved its mobile development. So before we make the change, so we have to say that whatever changes or improvement or evolutions of our code base, there are some goals and guides that we want to reach. So the first goals, we want to make sure that whatever changes and improvements we want to make to our architectures and things, it has to be, first of all, scalable. So whatever approach, it has to be really scalable. Secondly, it has to be flexible. That means we can change, evolve things very fast. And thirdly, developer experience. In fact, that's one of the most important. Developers will like to work on the code base. So, and then the guide is whatever we are working on, we try to be as close as possible to the platform, iOS or Android. So native developments, we are working on iOS and Android. And then we are trying to go to adopt all the industrial trends, technology we have for Swift and Kotlin. So these are all latest stuff and newer stuff they want to do. So these are like very good goals and guide. So that's our principle of how we want to evolve our technology over. But we don't start with all this. We start off with back in 2014 when there was this iOS and Android things. We have to go through evolutions of 3 eras. The first era I call it the monolith era, and then it is good, it helps us, but then it's not as good as what we want. So we evolve into something called federated era, and then finally we get into what we call the app as a platform era today. So how these 3 eras changes and evolve, I'm going to give you a little bit more detail on that area. So back in 2014, so in the early days when there was this web development, so there are services servicing to the web and everything, which is good. But then later, once we have iOS teams, we build our iOS with all the new code base we have, Objective-C's, and later they change to Swift and UI kits, the MVC patterns, Cordala. So we kind of learn the teams, and then along the way, Android came into the picture. So we have Android, a lot of Android technology came out. SQL likes, Dagger tools, XML layouts, MVP. So the Android team. So these are clear, distinct teams that works on the platforms that we ship to our user. And we bring on some of the consultants to help us on the projects. And later on, we come expand the works further. And then we have become more independent as the groups work on this project. So this is good. This is helping us because we are able to ship out to customers and use our apps, and there are millions of customers using the app, which is awesome. But there are some problems that we are facing that we need to solve. First of all, iOS and Android are very two distinct teams. So each of them are actually different teams in terms of technology, in terms of design, how they work on it. So it's all two distinct teams. So and when products want to do something, they have to talk to two teams. Secondly, the structure become a little bit messy over time. This is not because we don't know how to do the work. Because at that point of time, iOS and Android evolve a lot in terms of their technology. It changes so much. So things becomes a little messy. There's a lot of tech debt, so-called. So we have to solve that. Thirdly, because these are bottlenecks because the business keep asking us there's grow and more demands for mobile development. So we have to have more features to get into the app. So but we only have one team, Android and iOS. So the last problems we have is always mobile is kind of a byproduct because web is like a first citizen back then. So these are all four problems that we have. In looking at all these four problems, we try to solve it. That's why we evolved into the second era, what we call the federated era. So in the federated eras, what do we do? So this time, instead of having an iOS and Android team, let's merge the team together. Let's have iOS and Android as a single teams. We build and release, we build something called architecture team, which provides all the base layer, the networking, analytical, authentications, dependency management. So all this architecture stuff is managed by a team. So at the same time, we also build a backend for front-end services, which provides much more priorities for the mobile development. So that is like kind of, improve, shield the changes from the web to be affected on the app. So, and then we also introduced what we call a feature team. The feature team are responsible for developing all the features that's facing the customer or the user that is using it. So, but at the same time, we know there are requirements from other businesses unit. So we allow all these businesses to federate their changes into our code base, make changes so that we don't need to worry about scalability. We are able to scale much better in that sense. But then we don't have some sort of very good structure within. So there are some challenges that there's some teams federated in various different approach, and then the internal structure is not as very clear. So the boundaries between features as well as architecture is not as clear. So there are some works that cross across architectures and features within the same code base. So from here, and then there's also another thing is we do have modules within our apps, but then what about the back end for front end? So you probably can see some sort of congestions over here that we need to manage. So by looking at these problems, we know that we need to evolve further. But before we look at all these problems, right, we have to look at what was the previous problems on the monolith that we have. So all the previous problems that we have on the monolith, in fact, we have solved it using the approach that we have this federated approach. We have a joint iOS teams, we are much more modularized base, and we have a federated deliveries allow other businesses to work into our code base. And then we also have a mobile BFF, which like give some priorities for the mobile works. But nonetheless, there are challenges that comes into here. It's a single custodianship models. Like anybody want to put on their code changes into our app, they have to go through the feature teams, and the feature goes through the architecture teams to put on make changes. So there's a lot of single custodianship bottlenecks happens here. And then the structure is pretty vague. Sometimes it's not very clear where the federated teams have to put in codes and things like that. And also there's a lack of autonomy and ownership because feature teams, they kind of contribute to the code, but they don't own it. So it's not part of their responsibility for longer sustainability of the code. And then the last one is there's also congestion in the backend for front end, as we have seen previously. So by looking at all these problems, this the whole piece of code, although it's much better in the earlier stage, but then it becomes a big legacy code that we have. So it backs to the previous image that I previously showed you. So it's kind of these big legacy projects that we have today. So the next question is, by looking at all these problems, how should we solve it? So that is where I'm going to share with you our approach of app as a platform. So the way we solve it is instead of growing it further, what we do is let's shrink it. Let's do something. Let's not build a feature anymore. Let's build something called a platform. Make a platform for the app to be worked on, to be contributed. And then all the little features that we have, we want to put and ship to the user, we call it a micro front end or MFE. And each of the teams will have to work on this micro front end, and they can bundle together and ships together into our platform and get it shipped out to the customers. How was this done? If I want to give you an analogy, I know analogy is not the best thing as mentioned just now, but yeah, it's a good analogy if you look at how, but before that, sorry, what is MFE? Micro front end. So micro front end is actually, it's not a term coined by REA, but it's actually a standard industrial terms by ThoughtWorks. Micro front end is actually an architecturally styled where independent deliverable front end applications that are composed into a greater whole. So the main keyword here is independently deliverable. So it's like it's not really a module, but it's actually an independent applications by itself. It's something very similar to microservices, but it's more on the front end. A little bit of things, a little small things that you can ship by yourself and can be used composed by yourself. So that's what we call micro front end. And to do that, so the analogies that I'm going to talk about is assuming right now you have an Android devices, right? So the Android team provides you SDK, so we can use on all the Android frameworks we have. And each of us can build a small little thing, and we can build an app and ship it up together with the Android devices. So a user will use our Android devices. We have all the apps they have in place, but Android teams, so Google teams, does not need to build all these apps. They just need to provide that framework, that platform, and all the companies can build their apps and put on the Play Store, and we can ship it, and user can use it. We are using the similar concept on at RA, where our app is no longer really an app by itself, but it's actually a platform where we have an app shell layer, and then also we provide some sort of foundations that each of the team can use. And when they use this foundation layer, they can build their individual apps as they like, and then bundle it together, and then can test it, and then we can ship it, put it something called in a RA apps library, and can be used individually, can test it individually, but also can be bundled into the entire apps and get shipped. So that is how we look at the whole our app system. Is no longer one app. It's actually multiple small apps that get bundled together through our platform. And all these little apps we bundle together even within our app store. And this is what our app store looks like. So it does have like all the little apps. User can just download it, and tester can just download it and use it. And then for experiments and usage. So that's so good. On top of that, what is app shell layer? So the app shell layer, to give you a clearer illustration, is app shell layer is almost like almost every single app that we have. It has configurations, entry to the apps, but the one special thing on this app shell layer, different from like normal apps, it has something we call an app frame and routing. The app frame and routing is basically a place where each of the little apps can be hosted, and each of them are actually managed through something what we call the router. So we have a router mechanism that manage and route through all these little micro front end that we have, and place it in the relevant places where user can access. So once we have that, then user can access each of these micro front end features individually. Of course, when we also support deep link. When there's a deep link into our applications, we will be able to take up the respective micro front end and surface it to the user and how it looks like. So to give you much more deeper details of how it looks like further, so if we evolve into app frame and routing, actually app frame and routing is just at the top level, we route to each of the little apps. But within each of these little apps itself, it does have its own features. It does have its own routing capability that you can route and manage. And with that, you can look at them. They are very flexible. They are very independent. They just need to like link together with each other. So they are actually individually done. A little small application, something fun to work with, something very nice to work with. And that is how then we bundle them together through our routing mechanism. And from here, so each of them are actually owned by individual team. And individual team makes their own decision of how to manage all these apps. And once they are good, they ship to the library, to our RA app library for testing, and then eventually bundle them together to our RA app and ship it out to the user. So from here, then we put out to Play Store and App Store. And of course, our app is also shipped to our library for use. So they give every single teams have their own autonomy of what they want to do and how they want to do it. At the same time, we also have alignments using the library we have. And when you look at this, basically it's an autonomy and alignment, and the whole concept that comes into a play, very famous term that is used, so very aligned autonomy. Well, they have the power to do what they want, but at the same time, we are all aligned using the common library. So how this aligned autonomy was achieved is like having ability for them to share some of the features. So we want them to use as much as possible routing to share some of the features. We use the foundations, which I'm going to talk about, to share some of the features. We use duplications. But there's one challenge. If there are some areas that doesn't make into these areas, we do have another categories called the components layer. So as we talk about what is component layer, so the app shell is at the top, the foundation is at the bottom. So, and all the micro front end is at the middle side, where it's owned by individual team. But when they need to share some of the items, what we introduce, we do have something called a component layer, where each of the micro front end are able to connect to other micro front ends components layer. Because the reason is we don't want to have micro front ends have the direct dependency on each other, but they can reach out to the components layer of each item. A team doesn't need to always have a micro front end. They can just have a component layer, assuming that the component layer can still be used as surface in other micro front end. So that gives the options of each team doesn't always need to own a micro front end by itself. And what is the foundation layer? So the foundation layer is basically areas where we have the common micro finance needs. Every single micro finance, whatever they need, like very basic, simple things like networking, analytics. So we have that foundation layers that support, and it does provide some sort of sensible default that can, for example, if you have if we talk about experiments, you will say let's use Firebase. So that sensible defaults will be the one that is on the foundation layer. It also allows the apps like the MFE to mock that sensible defaults or make changes and then make it more extensible and abstract. So with that, the examples of like foundation layer have is two. One is called the capability, which is all the capabilities. And networking, we talk about logins, routings, analytics, authentication, experiment, state management. So anything that's generics across all the micro front-end. The other one is the design kit and design system, colors, font, typography, space component, which is almost very similar to the other talks at the other side, which is, I guess so. That's ANZ though. Anyway, so foundations within foundations itself, there's also certain patterns we kind of need to adopt to make sure our micro front end are able to extend beyond one app. So assuming we have one of our micro front end, one of our apps is micro front end one is being used in app X app, okay, and then it's also being used by X Y apps. So and in YX it just needs like optimizely for experiments, and X app it just requires Firebase for experiment. So assuming if we have a ways where we talk a normal object-oriented approach, where we kind of extend our foundation layer of experiments using Firebase, so there will be a relationship of micro front end one tied to the Firebase. And then when we go to Y app, you have to tie to optimizely. So that makes micro front end just it's not as extensible because it kind of has to link to two like different libraries that we have. So in order to solve that problem, this is not a very good way of like linking up the relationship. A much better way of linking up the relationship is let's do a reverse type of dependency. The micro front end should never depend on very specific, experiments. They should always depend on the abstract layer of experiments. Whereas it's the apps that is the one that set up and decides what experiments do we use. So that is another principle that we use to apply for it. So these are all about the technicalities of how we manage that app, our app as a platform. But there's also very, very important aspect is what found it at the organization layer, how do we manage that? So as mentioned by Melvin E. Conway says that any organizations that design a system will produce a design whose structure is a copy of organization communication structure. So within REA, how do we manage all these like different teams that we have? So as we have seen previously, we have an app shell layer on the top, micro front end and foundation. So which team manage which area? So we do have a team that actually manage the platform layer, the overall app shell as well as capability. And then we also have another team that manage the design platform area. And then after that, there are all sort of like micro front end teams that works across all the features that they have. So clearly there's this horizontal line that communicates within the teams. But then for us to work more effectively, it's very important for us to have also something across team collaboration. So we do have activities like leads forums that manage through the rest of the teams. We also have like weekly guilds and dojos. We have boot camps, master classes. We have like yearly events like Tech Summit, the Dev Days, and manage through. And then we also have departments that actually manage through all the CI. We have a CI Friday, cross-functional PRs, some junior support teams, and we do have a DevOps and tech support teams go across the rest of the teams. And last and not least, and of course, tech architecture work groups. So this is basically that whole frameworks, organization framework that we have, that when we put together, bundle together and enables how we work on as an organization for our mobile developments. So with that, if you were to evaluate how we have done so far, by looking at how is it scalable, is it flexible, is it developer friendly? So far, like it's scalable because as we can just add new micro front end easily, and then it's flexible because each of the micro front end have their own decision. They can make it, they can extend it, and developers are very happy working on it because each of them are very small code base. And even if there's a tech dev of the issue, it's all within their small little domain that they can just manage. It's much more manageable. So that is really good, but nonetheless, you know that every good thing have some challenges, right? Monolith, when we compare the monolith and app as a platform architectures, it's much more better in these new architectures where we have a clearer code base, ownership of all features are very clear, team agility and autonomy is much better, faster build time and CI because each of the apps, little apps can be built individually. But then when it comes to integration and debugging, there are some challenges because you have to integrate everything together, and dependency synchronization is also a big challenge, as well as whenever we need a common infrastructure upgrade, we need to handle that. That's also a challenge that we need to handle. So we are currently at the stage where we are trying to explore what it would be the best of the both worlds. So we are actually having a ways to do that. Maybe that would be a talk in the future, but that is already underway. So far I know that we are not really out of the wood yet. There are some of the challenges, but I think we are able to see some light moving forward for us to scale our mobile development. I hope this shares beneficial to you, and the credits goes to the entire teams, the architecture teams, the tech lead teams, the mobile teams, the MFE teams that works on all these things area. So that ends my talk. Thank you very much.
Thank you. Any questions? Oh, very quick.
Thanks. That was a great talk. Like microservices don't really have a front end, so they could talk over, I don't know, HTTP or with message passing or anything. So we don't really need to care about like how it bundles up and how it looks. But for instance, with micro front ends, I'm just giving a random example. Let's say the REA logo changes a bit. That should come in all of the 8 apps or how many ever apps you have. How would something like that come with micro front ends?
Sorry, if I get your question, is like how does the micro front end work across all the apps?
Yes, and for instance, if there is change, for instance, like REA logo changes, and that should come into all of the apps that are using it. So how is it like? How does it ripple effect into all of the apps that are already live?
Oh, okay. Hopefully my illustration was clear. Each of the micro front end are individually managed by the team, and when there's a change within the micro front end, the features, right? They just make the change within the micro front end, and then it's already connected or kind of bundled together with each of the app that they're going to ship to. So as long as they get merged into those apps, then the single change get propagated to all the apps. So yeah, that's the way it does.
Okay, thank you.
No worries, thank you.
I don't think you explicitly said this or not, but it's kind of a two-part question. So what you were saying about dependency synchronization leads me to believe, are your micro front ends all in their own individual Git repositories? So like totally isolated from each other? Is that?
A very, very, very good question. In fact, that is one of the things we have experiments. We have break our projects. Initially, everything was in a single code base. So we have broken down, because it was so close together, there's no very clear boundary. So we have broken down into polyrepo. And that helps to ensure clear separations across the team. So that is very good in help. But as I mentioned, the problems comes into all the dependency and management, which I shared in the last slide. We are actually exploring something called monorepo, getting together and linking up all the foundations.
Okay, cool. No, that was going to be my question, was why did you decide to go one way or the other? But it sounds like you're exploring the other ones.
Yeah, very good question.
Any other questions?
So can you give us a rough idea of what's the percentage of people working on features versus all the other support around it?
I think it's probably, as of today, maybe 20 or 15% or so more on the platform, and then the rest are more on the feature side. But the feature can scale on. Yeah, that's currently what we have.
And the follow-up question is like, how big did the organization face the problems before you got to lock in that percentage? Because you probably started from zero, right? So how did you convince stakeholders to put the effort in there?
Yeah, that is a management type of questions, which is very valid and valuable. We didn't change immediately. The nice thing about how we evolve is, as you know, that there's a federation era that we go through. during the federation era, we already have some sort of architecture team and feature team. And then architecture team slowly evolved into a platform team. So we kind of got some free ticket on that. But if you want to go directly jump into, yeah, it will be a hard conversation.
Any more questions? Oh,
Thanks. So my question is like, I think for your mobile team, you went from the monolith to now the new kind of structure. Is it still the same mobile team you had in the beginning, and how your like your mobile team was affected by the changes?
So this spans through 10 years. So there are people who come and join and left all these things. So the actual team is most of the people are no longer with us. There are some existing there. Of course, there are still some old timers. So we evolved. The reason we evolved it, there are some team members in the architecture team are existing team, but not all evolved. So, but the whole thing is when we evolve into a much more smaller scope and much more clearly defined scope, it's much more easier to bring people in and train them on that scope. And so we do evolve. It's not really the same team anymore. It's just evolve.
I guess my question is like, overall, is your mobile team happy with the change, or they don't like so many changes, or they don't really like the new current structure?
The answer is, I hope I'm right. So far, what we hear from the team are they are pretty happy. And to be fair, as we show through the era 1, 2, and 3, right? There are some codes still within era 1, and which is planning to transition into era 3. The developer that has to work on the era 1 code is not very happy, but we tell them that let's move on to era 3. They are looking forward to that, and they are saying this is really good because then they doesn't need to worry about all this big legacy code base. They can work on their small little code base. So they are pretty happy on that, I think.